We are going to try to maximize the 1,000 meters squared of material we have, and we're going to try to do it with a rectangular prism. So the rectangular prism has 6 faces, and all of the faces are rectangles. We know that to maximize the area of a rectangle, we need a square. So let's try to do ours with a square base. So we have a base, the length and the width is b, and a height of h. Okay, so what do we know about this? We know that the surface area is equal to 1,000. So we could use the formula we have here, 2 times width times height plus length times width plus length times height. But in this case we have a lot of repeated values, so let's just make up our own formula. So we have 1,000 equals, okay, so we have the base is this square here, and the bottom is like that, and the top. So we have 2b squared. The area would be b times b. There's 2 of them. 2 times b squared. Just going to erase it from the shape so we can see all the other faces. Now, all the other rectangles are base times height. Every single one. Base times height, base times height, base times height. All 4 of those are base times height. So we have 4 base times height. Okay, so this is an equation for the surface area. Similar to what we did for the cylinder, we want to be able to pick one of these values and solve for the other one. So we want to maybe pick b and solve for h. So we'll need h by itself. So we're going to use the same steps to isolate h. We're going to have to subtract the 2b squared from both sides. 1,000 minus 2b squared. We subtract it from the right-hand side, so it's gone. And we have 4bh. Okay, we want to get h by itself, so we can divide by 4b. 4b. And we'll have 1,000 minus 2b squared over 4b is equal to h. Now, technically over here on the left-hand side, we could do a little bit of simplifying. Every term here, every single term are even numbers, so we could divide every single term by 2. Divide the bottom by 2 and be left with 2, and divide the top. When we divide the top, we have to divide both terms. 500. 2 divided by 2 is 1. So we can simplify this a little bit more. H is equal to 500 minus, that's looking very messy and not quite correct. Okay, we had 2 and we divided by 2, we were left with 1, and we still have the b squared. All over 2, all over 2b. Okay, so now we know what h is in terms of b. If we pick b, we can find h. Let's write an equation for the volume. So the volume of a rectangular prism is usually the area of the base times the height. Area of the base is b squared, times the height. We have the height over here 500 minus b squared all over 2b. Great. So now we have this equation and we can use it to graph the relationship between the volume and the choice of variables. So I'm going to make a new graph here. Let me pull this down so you can see all the buttons I'm pressing. So if you want to make it in GeoGebra, you can too. Oops, don't disappear, GeoGebra. Okay. So we want to input this, and remember we have to be careful when we input it. Hopefully we'll do it perfectly the first try. So we have b squared, and remember that GeoGebra doesn't want any random old variable. They actually want us to use x's. So x to the power of 2 times, in the numerator, 500 minus b squared. Uh-oh, it didn't like that b. I better go back. It's expecting x divided by all of this. We'd want to put brackets around the denominator so it knows it's all in the denominator, divided by 2x. I opened 2 brackets, 3 brackets. Have I closed all my brackets? I think so. If this graphs, it should be correct. Okay, we can see it starting here, so let's adjust the scale so we can see what's happening. We don't really see much of the behavior. All we see is a big, huge vertical something. We don't even know if it's a line or a different shape until we zoom in more. Okay, let's try to find the maximum value. And oops. I like to be able to see over here. We can see this point. Okay, what's the maximum? Just play with this point a little bit until we get a maximum. It looks like it's 21, 51.66. I think so. I can use the arrow keys to move around, but they do jump quite a bit more than I want them to. When I was dragging it, I was getting more precise. So okay, I think that's the best we can do. So let's write down this point. Looks like it's the maximum. 12.92, comma, 2151.66. Is that right? 2151.66. Okay. So this means the variable we had was the base. For a base of 12.92, we have a maximum volume. This was our maximum volume. So what this shape means, you'll study it more in grade 10. This shape's called a parabola. It's like an upside down U shape. And wherever this parabola has the top of the hill, it's a maximum value. So since the y values here represented the volume, it's the maximum volume. And if we had a different shape, and if it was a u that went in the other direction, like say, let's see if I can get this shape to change. So it's not quite a parabola, it has some other dips to it, but it's a curve. We can say it's a curve. So with this curve, it has a minimum value right here. It dips down, hits a minimum, goes back up again. So it's often very helpful when you're doing an optimization problem to be able to find the highest or the lowest, because it might represent the best of something.